Hello, my name is Navneet, and my teammates are Banu, Pawan, and Karthik. And here's our project Sign Language Translation using Computer Vision. Basically, our project falls under the category of human computer interaction and tries to recognize multiple alphabets, digits, and several typical Indian Sign Language hand gestures. Sign language is a visual language that uses hand gestures, body language, and facial expressions to convey the meaning. Sign language translations can reduce this communication gap by allowing people who do not know sign language to understand what someone who is using sign language is trying to say. So let's talk about our problem statement. Sign language has a huge library of emotes which uses hand signs and to visual expressions of face to translate into many phrases. While learning the basics is not that tough, but learning all the phrases in the book is a quite tough task for anyone. So we present a translator which translates these emotes into English in real time.
Okay, now let's see into methods to collect the data. There are several sources where you can obtain data for sign language detection. One option is used to publicly available datasets for sign language detection, such as world level American Sign Language dataset, Indian Sign Language dataset. Another option is to collect our own data by recording videos of people using sign language. You can use this data to create a dataset that is specific to the sign language you are interested in detecting. So, we are going with the second option. We have created our own data by training the model. We have done the labeling for the data so that the dataset can be used to train and test language translation. Our let's see the approach towards our project. Here we have created our own data. So first thing we do is to pre-process. After pre-processing the data, we apply following methods such as OpenCV, LSTM. OpenCV can be used to process and analyze video data of individuals. We use our pre-processed data so that OpenCV can perform computer vision operations on the data. This operation helps us for detecting and tracking the individual hands and facial features. Recurrent neural networks, such as long short term memory, we shortly called as LSTM, are a type of artificial neural networks that can be used for sequence prediction. In sign language translation, we use LSTM to detect the sign from the given video. Media pipeline is helped to connect all these. Media pipeline is used to build machine learning models and running inference on various type of input data such as video and audio streams. Media pipe can be used for tasks such as object detection and tracking in video. So here we use it for gesture recognition.
So now we'll look into the core part. Firstly, we'll import the required imports required to build this application. Then we'll look into the OpenCV part where it's main the main function of these both. I think there are 3 to 4 functions here. Its main function is to create the checkpoints or known as knuckle points, so that the OpenCV it's mainly for the model, for the CNN model or the LSTM model for the use to understand the video or the image for easily. Like it gives the perfect knuckle points or checkpoints. So here we are used some basic code. Like if we have drawn some landmarks for the face connections, left hand connections, right hand connections, even for the pose of the torso. And after that we have drawn the similar things. It's of various dimensions. After that, there is a function which will extract the key points and it will show it on our camera, like on interface, which would be it's basically the PyCon, which we'll see later. So after that, we come to the data collection. So here, the main process of data collection here, the data is not from anywhere, so we have to basically create our own data. So what we took was we have created a directory, then created sequence. It's a video which has 30 frames differently, and each frame is represented 30 times in the data. So here, basically, you can add how are you or anything else like hi, hello, hi, or anything. How are you today? How you doing? How you doing? Then we have the number of sequences and sequences. After that, we have the actions. Like this will create a different folder for the phrase how you doing. We'll do that. After that, this is mainly for capturing the new data. I'll probably not run this because this will create a long video, I guess. But the main idea behind this is here there's a confidence and confidence of 0.5% to maintain that not every small detail like uneven data is registered here. After that, there's frame reading, the reading and media pipe detection from the media pipe library. After that, drawing style landmarks from the OpenCV above. After that, there's some mechanism to set the data collection here, same here. And after that, add that data points to the physical data like physical data set we had here, and the queue function to break the flow and release the camera. So it's a basic data collection window. We'll look into this later, or we'll directly look into the results obtained from this. So then we have the emotes. Like these are previously some of the emotes I took for the previous test. Like here you can add something other like how you doing, how are you, how are you doing, anything, how are you doing, how are you doing, any phrase. Just took the phrase we added before, yeah, how you doing, and then we'll use the actions, and pair it out emotes, which will just give them a numerical form. And after that we'll go into the model. Model we took the LST model here. So these are basically some train test spread to categorical, some label mapping, the customs for just data pre-processing to the model. So we'll just run these things. Take some time. It's a long process when we are taking a huge number of data sets, data labels. Yeah, here you can see the four amounts we just gave away for the previous test. Yeah, for now test. Then we have the labels depending just label them. Okay, the data path is not. Yeah, this is actually quite a bit common because we haven't added the data for how you're doing, so it will probably not give that. Um, uh, it's a better thing if I just don't run these sets because it will create more further issues. Like just go on with the code. Like then here we have the open listing, converting the frames into NPEG format, and then we have the X test Y text. Here I took 70-30 rule for dividing the data into training data and testing data. Here I use the STM model. So here we have the architecture of the model, sequential 64 kernel, the dropout of zero point 0.4 from the input to the hidden layer 1, then LSTM under layer dropout of 1.4 LSTM dense layer. So this is basically the uh, regular machine learning part. After that, the final activation function is softmax. And then we come to the optimizer. It's important to optimize our model for better results. So here where I've used Atom optimizer with loss going for categorical cross entropy metrics being categorical accuracy. Uh, let's see if I can run this. Okay, let's see if I can run this. I haven't run the model part of it. No issues, no issues. Because I haven't given the data on the above, it's not that much prescribed to run the model now. And after we ask for the model to predict these things. After that, we have the saving of the model and testing this in the real time. So we'll first save the data, load those weights again, and then asking the computer to give the confusion matrix so that we recheck that we are on the correct path. So we check the accuracy, and then we have the final testing part. So here we only predict a label, and like we only result a label when it has a confidence of at least 80%. So here we have the same a similar architecture here as of the data collection. It has some minor changes for adding the labels and correctly picking the signs. So here let's check here. Yeah, the Q is for the breaking the windows and showing this off. So this is the basic code understanding. Now we'll look on to the application part of this.
Now we will see the application part of this. Firstly, restart the kernel and go down to the data collection cells. Now I'm adding data for the emote. How are you? So I'll just edit this and run the below cells. So we have completed our 30 repetitions. This is how we have added the data to our dataset. Now we will see the application working in real time. Adding the new emote, how are you? We already have the data. Let's quickly run the application. So running all the cells. So here we can see how the model is accurately translating the given sign. This is how the application works. Now as we are on to the conclusion, the two major steps in building this application are data collection, model training, testing and validation. Here we have attached some results in the slide. Finally, thank you sir for giving us this opportunity, and this is our team.